Protons. Let's just go through what we know about the subatomic particles. Jack, what do you know about protons? What's their charge? +1. What's their mass? Pardon? None. They have no mass. Anyone have a disagreement with that? Phil, what's their mass? 1. It's about 1 AMU, which is an atomic mass unit. That is not 1 kilogram. I log it. Location. Where do we find the proton? Right. Nucleus. Very good. Mariam, what do you know about the charge of a neutron? Very good. A bit like Switzerland. Mass? Mass? Yep. 1. Where do we find the proton? The neutron? In the nucleus with his buddy, the proton. Nucleus walks into a bar, says to the bartender, how much for a pint of your finest ale? And the bartender says, for you, no charge.
I get it.
No. Electron. Charge is what? -1. What is the mass of a electron, Noah? Mass of electron? Because I just asked you the question. It is very small. It's not 0, but relative to the others, what do we consider it, Emily?
0.00.
Yeah, so for all intended purposes, we're just going to call it 0 AMU. If you want, it's 0.001 or something of a proton and a neutron. Where do we find the electron?
Orbiting, right?
Orbiting. Very, very good. Now, I've asked us to draw a carbon-14 atom. I would hope that this was done in a reasonably neat way. I'm going to try my best to do it as best I can. So in my red, I have little pluses. What do you think they represent?
Protons.
Protons, very good. I'm going to put some black circles in there. What do you think they represent?
Neutrons.
Very good. How many protons do I need to have? 6. How many neutrons should I have?
8.
How do you know I should have 8? Very good. Now, assuming that this is a normal carbon atom, how many electrons would I expect to see? How many in the first shell?
2.
How many in the second? Run out of room, so I'm just going to draw it like so. Hands up if your atom looks something like that.
I just need them, so yeah.
Okay, but if you hadn't quite got to that yet, if your atom, Andrew, would look something like that, is that what it looks like, Andrew?
Yes, it is.
Very good. So you can tell me the model that that represents. Because in Year 10 we use a model of the atom, which we call? Many students consider it a boring topic. Thank you. We use Bohr's atomic model.
Oh, okay. I heard the smell one.
Now Bohr's model oversimplifies what is actually going on. We know that there is more advanced models available. Why don't we teach these in schools? Basically because it does get quite complicated, and the mathematics you need to understand that is beyond your concept. This does a very good job of explaining most of the phenomena inside an atom. So for example, one of the advancements that Bohr's model made was that electrons can go in these shells, in these orbitals, but they can be excited and moved outwards. And when they give off energy, they can come back inwards. If we give it an electron enough energy, what happens? The electron breaks off, runs free. Okay? So in this model, electrons orbit the nucleus and can be excited if given energy. So if you give an electron in this model energy, it will be excited. It might jump to the next level and then come back down, and when it comes back down, it will release the same amount of energy it absorbed. If you give it too much energy, it pops off.
You know, you said how they jump up like this. Isn't there something to do with colour?
Yep. So with neon lights and with fireworks and a lot of different things like that, where we excite something and see a colour light produced, even the northern lights, for example, what's happening is those electrons are being excited, going to a second or third shell, and when they pop back down to their original shell, they release the energy. Light is a form of energy.
Stop raining.
Very good. Atoms are called isotopes if, Beth.
If they have a different number of neutrons in them.
If they have a different number of neutrons in their nucleus. Very good. Different number from what?
The normal number.
How do you know the normal number of neutrons?
It's on the periodic table.
It's on the periodic table. Very, very good. Or, actually no, it's on the periodic table. That's good. So carbon-14 is an example of an isotope. It's an isotope because carbon normally has 12, which means it has 6 neutrons. In this case, it has 8. It has a very, very long half-life, which is why we use it for carbon dating. So carbon dating uses the half-life of carbon-14 to find out how long a fossil has been dead for. How long since it stopped breathing in oxygen and taking in food. Atoms are called ions if, thank you James.
Different number of electrons.
So why do you think we call radiation that is harmful ionizing radiation? Jack? Why do we call radiation that is harmful to the human ionizing radiation?
Because it takes away
Atoms? What does it strip? Strips the electrons, which is not good for things like our DNA, for example. Now, positive ion walks into the bar.
Yes.
Says to the bartender, I've lost my electron. He goes, are you sure? I'm positive.